Alright, so lesson 63, question B. Convert to polar coordinates. Negative 15, 3, that's rectangular form. That's our x, y coordinate, the one that we're very familiar with. And we're going to turn it into this polar coordinates that's going to be something r comma theta, which stands for the radius and the angle. So let's take a look at what we've got going on here and see how we do this. So if you just draw a coordinate plane here, make sure the x-axis is nice and long. We'll just call that negative 15, and we'll say that's probably around 3. So there's our coordinate there, negative 15, 3. Now we're trying to get to that point, but we want to get there not by going left and then up, but by kind of going out at an angle straight to that point. The line, the distance that we go out is going to be the radius, and the angle that we turn ourselves to face, right? We're going to just kind of twist ourselves around from first we were pointing off in the positive x direction, and then we just spun around until we were pointing at that blue, in the direction of that blue line, and then we started going out some distance until we got to this point. Okay, so that's just, it's just a different way of describing how to get to that point. So before we used to describe it as first go 15 steps to the left and then go up 3 steps and then you're there. Well, now we're going to say rotate around to a particular angle and then go out a particular number of steps in that direction. Okay, now notice, just by kind of describing those two, I just fashioned a little right triangle here. A right triangle that has one leg that is 15 and one leg that is 3, forming a right angle. And then the hypotenuse is the kind of the shortcut, the line that connects straight to the point. We call that the hypotenuse. It's across from the right angle. And that kind of calls to mind this formula, a squared plus b squared equals c squared, the Pythagorean theorem, that we could use for this. That would be x squared plus y squared equals r squared. That's just the Pythagorean theorem applied to the x, y, and axis and the radius for the polar coordinates. That's the relationship between them. And so for us, we would just do 15 squared plus 3 squared equals r squared. That's 225 plus 9, which is 234, equals r squared. And then we do the square root of both sides, and r equals the square root of 234. Okay, that was easy. We could turn that into a decimal by typing in our calculator. I prefer to leave it as in the most accurate form, which is the square root form, but the book, I think, does give the decimal form of that. Okay. Now, notice that I didn't bother with the negative and the negative 15, and that's because if you took negative 15 squared, that'd just be negative times a negative is positive anyway, so it doesn't matter if you are careful with the negatives here. Now let's think about the angle. We're trying to get that green angle from the positive x-axis all the way around there. But we have this kind of red triangle that we've drawn, and within it, it has an angle that relates to the angle we're going for, in that together, that angle, the red angle there, that little tiny one, and the green angle form this straight line 180 degrees. So those are supplementary angles. So if I can figure out that little angle there, I could then subtract it from 180 to find the big angle. And that's what I'm going to do. I'm going to say, okay, I want to find that little angle. Well, I have the opposite side 3, the adjacent side 15. That's the tangent ratio. The tangent of that little angle there is equal to 3 over 15. So the little angle there is the inverse tangent, 3 over 15. So on my calculator, just type that in. I get approximately 11 degrees. It's a little bit more, but we won't worry about that. So that means that the big angle, the green angle, is going to be 180 minus 11, because together they add up to 180, they make a straight line. And we're looking for that green angle there, which we're calling theta. Okay, so theta is approximately 169 degrees. Alright, there we go. There's our answer. Now, you may be thinking to yourself, why didn't I use the negative 15? Again, is this another situation where it doesn't matter? Well, let's just say that we had said the tangent of theta, so I'm trying to get that big angle there, theta, is equal to 3 over negative 15. And type that in my calculator. So theta equals the inverse tangent of negative 3/15. Now try this on your calculator. What do you get? On my calculator, I get approximately negative 11 degrees. Well, what's up with that? Where's negative 11 degrees? Negative 11 degrees is down here. Negative 11 degrees. And that's because, this is a little bit weird, but the tangent ratio on your calculator only calculates tangents between 90 degrees and negative 90 degrees, only over on that side. And that's because there's a point over here that is 15, negative 3. That has the exact same tangent, right? 15, negative 3 would just be opposite, negative 3 over adjacent 15. The tangent is negative 3/15, just like the tangent of our point up here. So the calculator doesn't know, well, which one do you want to talk about? So just by default, it always goes to the right-hand side. And so when you're looking at your coordinates and you notice, well, negative 15 is going to take me to the left-hand side, then you know that the calculator, when you do this, is not going to give you your angle, it's going to give you the complement of your angle. So you have to take what it gives you and add 180 degrees. Negative 11 plus 180 degrees is what we're looking for, 169. Now, that just means that you have to be smart about this and recognize that if the negative signs tell you that your angle is going off to the left, then your calculator is not going to give you the tangent, it's going to give you the angle, it's going to give you the complement. Okay, so we found our r and our theta, we'll plug them in and write them down. Square root 234, comma 169. Again, I rounded the angle and I refused to round my square root. I'm putting it in decimal form. The book does the opposite, so just keep that in mind. All right. Let's give D a try. So D says that we have this function here, x squared plus y squared equals 9. I guess it's not a function, it's an equation. And this is going to produce this. We can graph this. It's going to produce some sort of shape on the coordinate plane. And the question is, could we write an equivalent equation using polar form? Well, first of all, we need to know what is this going to be? What shape is this? Well, we remember our formula. X minus h squared plus y minus k squared equals r squared, where h and k were the center of my circle, and r was the radius. So, for this case, we're just going to do the center at 0, 0, because there's no numbers being added or subtracted from x or y before you square them. So 0, 0. The radius is going to be, well, r squared equals 9, so the radius equals 3, because 3 squared equals 9. So we're just going to go out 3 spaces from kind of in every direction that I can count easily, and then we'll draw my circle. Alright, not a great circle, but you get the idea. So there's a circle, has a radius of 3, and that's it. Okay, now it turns out that that formulation, that equation, I should say, it's not a, what's a formula? It's not a function, is not all that handy to use in rectangular coordinate system. It works, but it's not easy to deal with. In polar coordinate system, we had a formula for a circle that was super easy. It's killer easy. It just went like this: r equals a, where a is the radius. In fact, r stands for the radius, and that's all it is. It's just the radius, whatever it is. R equals 3 would be the answer to our question. Now, it turns out that's the only, at least it's the only one I know of, the only polar formula and rectangular formula that produce the same drawing that you could switch back and forth between. In most cases, all the different graphs you get using polar forms are not easily reproduced using rectangular forms, and vice versa. So this is the only one, a circle, and in fact a circle with the center at the origin. Alright, so don't worry too much about this particular question. Obviously it's one you want to know about, but there's not a whole bunch of others behind it waiting to attack you. Okay, so what is making this one tricky is they didn't give this as one of the answers. R equals 3 is not one of the answers. It's a really good answer, but it's not on there. So we need to change this into some other form to match one of the equations in our multiple choice answers. I noticed as I'm looking across that a lot of them have an r squared in them, so what would happen if we squared r? Well, r squared would equal 9. So there's an answer. That one's not on there either, but we do have one that is r squared minus 9 equals 0. You can see where that came from, just subtracted 9 from both sides. So that one, it turns out, is the right answer. All the rest you can see have some flaw in them. Either it's a single r to the first power, and a 9, or there's an r squared, but it's trying to throw in a bunch of sines and cosines that aren't necessary. So I'll just give you one example. The answer D says r cosine squared theta plus r sine squared theta equals 9. Now this one is deceptive. It actually could be right, except that it was r, not r squared. Because if we factor out r, we're left with cosine squared theta plus sine squared theta, which is just 1. So 1 times r equals 9. Well, no, that's not true. It's r squared equals 9, not r equals 9. And so that's why this one's wrong. But it was close. We could have written our equation that way, as long as if it had either equaled 3 or the r's had been r squareds, then that would have been right. So it's important to recognize that they're trying to get you to manipulate things around here. Alright, thanks for watching. We'll try one more recording with question C.